So learning goal number 51 is going to be all about taking a linear equation and creating a table of values to go with it. Now we're actually going to jump into looking at graphing as well, which we'll do more of later on in other learning goals as well. But for the time being, we're going to look at the table of values and how do we graph that and how do we put that into a visual aspect of it. So let's start off with the first little bit here. A linear equation, okay, or linear function has two variables. Okay, often those variables are going to be x and y, but we consider them directly the dependent and independent. It's dependent variables. Okay, so we have our dependent and our independent variables. The equation that we're going to come up with, okay, so there's going to be some equation that is around x and y, is the relationship between those two variables. Okay, so it is the relationship between those two variables. Now, the way that they're related is all about how we use our operations. Okay, the numbers around there, the coefficients, the constants. That's the relationship that they go. It's kind of how is each one building off the other. Okay, so how is it building off the other? Now, the independent variable, okay, which we often use x for the independent variable. Okay, so if you see x, that's usually the independent variable, is the one that continues to rise and fall, okay, without any any dependence on any other factors. And so when we talk about factors, we're talking about things that will, change things around. The x variable can be kind of like time. It keeps on going and going and going. It doesn't stop. We continue to kind of see it progressing as we go. So that is the independent variable. We're going to consider that to be x. Now, the dependent variable, okay, depends on the value of the independent variable. Okay, so independent variable is that thing that's kind of like off to the side but is affecting change. The dependent variable is affected by that change. Okay, it is often on its own in an equation. Okay, so we often see this one all by itself, and that one is usually the letter y. Okay, so we usually use y as our independent variable. Now, a linear equation, what we're going to have is something that looks like this here. Okay, so we have y equals x, and then we're usually going to add some sort of operations to the x. Okay, so as I just said, operations can be applied to both sides. Okay, and this affects the way that the pattern goes. Okay, so it affects the pattern that we see. Every linear equation is a pattern. Okay, the y is going to be growing or decreasing based on the value of x that is in there and based on the operations that are applied to x. Now, a table of values can be created, or sorry, derived, use the right word here, derived using a linear equation. Now, derived just means that we are coming up with the values. Okay, we are finding the values, we are solving for the values, if you want to think of that as being derived. Now, here's our table of values. We have our x values and we have our y values. What we're going to be doing is to start, okay, we're going to choose 5 or more values of x. Now, sometimes you'll be like, well, what if I don't know which values to choose? Okay. Now, when we're talking about values to choose, what we want to do is we want to have a variety of values to choose. Okay. So we want to use always a couple of negative values, okay, potentially. So we're going to use a couple of negative values. We're going to use a couple of positives, which would seem kind of usual. And we're also going to use 0. Okay, so we're going to use 0 as well to get a wide range of values and to really see what does this equation do. What happens when there's a negative value? What happens when there's a positive value? Okay, how does the operations affect the pattern that is happening? Okay. Then what we do once we know which x values we have, and again, we can choose, we can do whichever values we want, but I'll give you some kind of ones that you could often use. Okay. Then we insert each value of x into the equation to determine the matching is going to determine the matching values of y. Now, when I say matching values, we're not talking that they're the exact same. So it's a 1, 1 or 2, 2. We're talking about the value which works in the equation as well. So the value of y that will give us the x, or the value of x that will give us the y. Okay, so that's important that we understand that. What we're going to do here is let's come up with our values. We have x and y. Let's come up with some negative and positive values for x. Now I'm going to use some basics here. I'm going to use -2. Well, let's not do that. Okay, I'm going to use -2, -1. These are some of my favorites to use. I like using these because we have some positives, some negatives. This is going to be 0, and then we're going to go up to 1, and then 2. Okay, so you'll notice that we have a couple negatives, we have 0, and then we have a couple positives, which is really going to give us an opportunity to see what does this equation do. For the first one there, so now what we do is we take the -2 and we're going to plug it into our equation. Our equation is y equals -2. Well, when we plug that in, we're going to get that, let's do it in equation mode here. Y is equal to 2 times -2. 2 times -2. Okay. Well, 2 times -2 is just going to give us -4. Okay, so when x is -2, the y is going to be -4. We can do that for the other ones as well. So if we put it in for y, or sorry, if we put -1 in, we have y is equal to 2 times -1. I got to make sure that I put the correct ones in there. And 2 times -1 is just going to mean that y is equal to -2. Okay, and we continue doing that. We do 2 times 0. Well, 2 times 0 is 0. This case here, it's a fairly straightforward operation that we're doing, so we can kind of do it without using an equation. But we have 0. If we do 2 times 1, that's going to be 2. And 2 times 2 is 4. So there we go. There we've created our table of values. We have some values of x, and then we have the corresponding values of y, which would be the matching ones based on the equation that we have. Now, if you want to always write out the equation, you can. You don't have to. But I did for the first two, and then we can kind of go through and do it without that equation. So that's our table of values. Now, a linear equation, okay, not all table of values are going to be linear, but a linear equation will always have an increase or decrease. It will always increase or decrease at a constant rate. Okay, so it'll always go up or down by the exact same amount. This rate, okay, will also be a part of the equation. Okay, so it'll also be part of the equation, and I'll kind of show you that as we go. It's always going to go up or down by a constant rate. And that is both the x and the y. You'll notice that the x is always going up by 1. The y is always going up by 2. So we have a 2 in here. Okay, that's in fact part of the equation that we're going to see in our table of values. In this case here, we're not usually the x's are going to go up by 1. Sometimes it'll go up by more. If x goes up by the same number each time, y is going to go up by a consistent number each time as well. We can think we're going up by 1, 1, 1, 1, going up by 2, 2, 2, 2. Okay, that tells us that it in fact is a linear equation. So let's take a look here. Which of the following table of values represents a linear equation? Well, what we need to do is see how are we changing each of these linear equations. This table right here, it's going up by 2, going up by 2. So we're adding 2 each time here. Okay, and consistently on. I won't write all of them in there. That could take quite a while. So we're always just adding 2 every time. on the other side here we're going to add 4. And then here, let's see, between 11 and 15, we add 4 as well, and then we add 4 again, and then we add 4 again. Okay, so we're always adding 4 every single time. We're adding 2 every time, we're adding 4 every time. This is a linear equation, or it represents a linear equation because it rises at a constant rate. Okay, because let's get rid of the e. Okay, so this one is a linear equation. It rises at a constant rate. So the x is going up by 2, y is going up by 4. Just like here, x went up by 1, y went up by 2. So that is a linear equation. This one over here, let's see if this one does the same thing. Okay, from -4 to -2, we're adding 2. -2 to 0, add 2. 0 to 2, add 2. We add 2. So every time we're adding 2. Well, that's a good thing. Let's try this one here. On the right-hand side, we go from 10 to -6, which is subtracting 4. 6 to 2 is subtracting 4. 2 to -2, subtracting 4. And -2 to -6, subtract 4. This is a linear equation because it decreases by 4 each time. Okay. So again, it's all about, is it going up and down by the same number each time? Okay. Now the x's have to go up by the same number, and the y's have to go up by a different same number each time. Now I'd like you to start by doing questions 1 and 2, filling up tables of values and determining are a certain table of value equal to a linear equation.